Well, thank you. Wonderful presentations. And we have in person with us here tonight, Dr. Verspoor, where it is mid-morning. Greetings from the evening in the eastern U.S., Karin, and we're delighted that you'll be with us for the Q&A session today. We have a number of interesting comments and questions posted, and the technology is such that only I can see them. So you're going to have to trust me that I am conveying them accurately to you. But we have people here in the studio who will make appropriate noises if I don't do that. So I think you can trust me. Okay, so the first opportunity for comment, it goes like this. I think there may be a big difference with mobility between LLMs and other forms of AI. And the difference is the control zone and who is controlling the LLMs. Can you comment on that?
I'm not entirely sure what the control zone refers to. But absolutely, the large language models are really, well, the ones that we have access to are controlled by the organizations that build them and make them available, right? So ChatGPT is made available to us because of OpenAI's efforts, and it is a black box. So in terms of being able to control like what is even in the box, we have no control and we have no information. They don't tell us what data sets the model was trained on. They don't tell us when it's changing. They don't even really advertise the prompt library that's used for doing supervision. They don't advertise really the supervision process at all. And so we don't have any way to kind of meaningfully evaluate and assess that system and definitely not control it. I guess I would say, though, that part of the conversation that you just heard Mark and I having is that even for symbolic systems at scale, this becomes a potential problem, right? Because if you have huge amounts of knowledge that are represented, it's very difficult to control kind of the quality of individual pieces of that knowledge. And, you can control the inference process, but you can't necessarily detect errors or problems that occur because of problems in the representation itself. So there are issues in both approaches, I would say.
Thank you. Next opportunity to comment. LLMs produce outputs that are okay but not precise. That is okay for the text says stating version. I think the intention is static version of a business document, but not for clinical decisions that require more precision. In addition, operating on clinical data means operating on very noisy data, incorporating random and systematic noise. Please comment.
Look, all data has random and systematic noise. And so, I think clinical data obviously has particular characteristics in terms of, even how it's documented, the sort of patterns of documentation, what's in there, the content, the specialized content. But overall, I'm not sure it's fair to say that in one context they're useful and in another they're not. It's more that the systems themselves as they exist today are limited and arguably not particularly useful for the kinds of goal-oriented and advanced decision-making tasks, which might apply in many different contexts. So I'm not sure the distinction is sort of clinical versus business, but rather the complexity of the data and the complexity of the tasks that we're trying to achieve with these systems. And I agree, what is in a large language model is literally the average of the data. So in that sense, it is rather kind of, banal in some sense, right? Because it's averaging all of the possible kind of contexts in which words are being used. And I think many of us have observed that, right? When we play with these tools, that they often come out with things that are just, not very interesting. And so if you kind of think about using that in a decision support context, we don't want the average. As individuals, we are not average. Our patients are not average. They are unique. And so that's really, I think, where the problem lies, because we want to be, we of course we need to abstract and treat our patients as members of groups, but these groups are extremely complex and nuanced. And so we need to have models that kind of understand that we're not just a big average of everything.
Yeah, and if I could just riff on that point just a bit, it goes to something I've often said about effective clinical decision support. It must tell the decision maker something they don't already know. And the more averaging that happens, the more likely it is that what the LLM is going to do is converge on something banal or something that the decision maker already knows, and in which case it can't be helpful. So
yeah, and this has been a problem in machine learning generally because because of the way they're trained, they're looking for patterns that generalize, and that means that essentially they're kind of capturing that sort of average setting that will transfer easily. And when we do evaluations, we find that the system evaluations are obviously biased to the more common things because, well, guess what? The more common things occur more frequently in the data. So we're testing, kind of the same scenarios over and over and over again. And it actually requires much more kind of targeted evaluation to understand how these models work in the more rare cases, and that just follows from the distribution of the data. Sure. So it's a very it's a problem across the board with models that are aiming to generalize.
Another, and this is interesting. A pharmacist colleague pointed out to me is the question asker, that we trust a lot of drugs without understanding their mechanisms. Is that a good analogy?
Yeah, so I actually think in general what has been done traditionally in medical research is a really good analogy for how we should be using AI in the clinical context. So definitely, we don't know much about the mechanisms of the drugs or exactly why they work in many cases, right? And we still trust them. Why do we trust them? We trust them because there's been a huge amount of evaluation that's been done on them, right? So we first of all start with animal models, and then we progress into human trials, and we collect evidence about both the harms and the efficacy of those drugs. We don't need to necessarily understand how they work inside and exactly what's going on in order to see the evidence of the impact, because we focus on the outcomes rather than the mechanism. And definitely we can see exactly that same opportunity here, right? That if we really kind of test and evaluate and rigorously assess the value of these AI systems, then we can certainly think, trust them at some level, because we have evidence that for particular contexts, for particular applications, they are effective. I think part of the reason, part of the point that we were trying to make around explainability is not that people need to understand the mechanism, right? We can, I've been going around explaining to people about these large language models, these generative AI systems anyway, being essentially next word predictors. And people are kind of getting it. They're like, oh, right, okay, I get now that's what's happening. But the mechanism for producing the language is almost beside the point at this point, because people see the outputs and they think it has meaning, and they attribute meaning to it. And so, yeah, it's a little different here, because we can we're communicating somehow with these models in a language that we share, right? Whereas with drugs, we're never sort of asking them, oh, how is it that you are doing what you do?
Talking pills. That's an interesting.
Talking pills, yeah. I mean, if we had talking pills, like, why do you work? It would probably, I don't know, would add a new dimension to our medical experience. But yeah.
Another point. A knowledge graph is deterministic. Same response with the same question repeated. Not an LLM. How do we get a ranked response from an LLM from the more likely to the less likely?
Yeah, so there are parameters you can control in a large language model application. Obviously, not in something like ChatGPT where you can't set the parameters directly, but internally you can control how dynamic it is, and there's something called temperature, which essentially controls how much variability that can be introduced. Obviously, to keep the text interesting, they want to have some dynamics in the outputs, because otherwise it would be completely deterministic. Now, if you have applications where you want it to be deterministic, right? You want it to be reliably producing the same outputs for a given set of inputs, then you can control that by controlling these parameters. Whether that exactly addresses whether that's a good thing or a bad thing, I think is kind of a separate question, and ultimately comes down to what is it we're trying to achieve. I think with things like ChatGPT, people value the dynamics, right? They kind of like that there's variability, especially if they're trying to use it, I don't know, to break writer's block, or to come up with a rough draft of a paper abstract or something. Those kinds of things, it's good to have linguistic variability, but in other contexts, that may not be so good. So yeah, we can control it to some extent if we have control of the model itself.
How much time do we have? 10 minutes. Okay. So next question. Isn't the major new thing here the realization that knowledge can be encoded in this totally new way?
Knowledge can be encoded in this totally new way. I mean, look, we've been trying to do this as a natural language processing community for a long time, so I'm not sure it's totally new. And in fact, large language models themselves, large language models are just bigger versions of language models that have been in development for quite some time. I think their scale, the largeness of them, really has taught us something about the value of data at some level, and the ability to model very large quantities of data with high fidelity, and that indeed is it's been a step change. Obviously, the public is now kind of aware of the capabilities of these systems in a way that just wasn't the case until less than 12 months ago. It's kind of crazy. So is that the key innovation? I mean, we have huge knowledge bases already, and just think about something like UMLS, right, which has been around for quite a long time. We've encoded knowledge at scale in those. It's not fully expressed knowledge, but even those basic kind of conceptual relationships between entities and concepts is valuable. So large language models are a different way and a less formal way of capturing knowledge. That's the key distinction, I think.
So do you know of much research, and you were kind of alluding to this a moment ago, that is trying to combine LLMs with knowledge or more traditional AI approaches? How hard will it be, and how promising is it?
So it's definitely happening, and there have been a number of efforts to essentially integrate things like knowledge graphs into the representation that's accessible to a large language model. And I personally believe that that's the way to go, because we've captured so much information in our knowledge representations and in ontologies and in semantics. It seems kind of crazy not to use that information. I have often been quoted as saying, "Why learn it if we already know it?" And so having these kind of hybrid models, I think has two benefits. One, the large language models themselves can be more sophisticated because they can leverage some of the semantic knowledge that's captured in existing knowledge structures. But second of all, it gives us kind of more ability to introduce some of that control that we were talking about earlier, because we can sort of grab onto the more conceptual elements that are represented inside of the model. It basically exposes. It means that the representation is no longer purely just mathematical weights and connections between these deep neural layers. It means that we can kind of explicitly introduce structured elements to the representation, which we can then control. So I think I think that's the way to go. And indeed, there are models that are already doing this. So the current version of the generative models that we see in OpenAI are grounded in something that was called BERT, that was built by Google in 2018, published in 2018. And that model, which was bidirectional encoded representation transformer, something like that. Anyway, don't have it quite right. The BERT model was purely based on word sequences, but then there were subsequent extensions of that, including a model called Ernie, which for those of you who like Sesame Street, you'll get the joke. But Ernie added in layers where they're tracking actually the parts of speech of individual words. So that's not getting to semantics, but it's starting to encode some syntax. And then it adds a layer where we can capture phrasal units and sort of mark those and make that kind of a little bit of structure available to the model in its representation, and you can extend from there. And so there are definitely people trying to kind of layer in different levels of linguistic or semantic knowledge into the representation.
So here's an interesting question, and I'm going to vary it from the way it's originally put. And this is an empirical question because we can run this experiment. What do you think would happen if we asked ChatGPT what Alan Turing would think of a large language model?
So, I mean, okay, it is a next word predictor, so it would probably find some text that had been written about Alan Turing and parrot us back whatever that text says. But I think, it would say, it's interesting because the OpenAI developers have clearly baked in a lot of sort of self-awareness, right? I suspect a bunch of that is templated rather than learned. But they will say things like, "Oh, I am just a large language model," or you shouldn't even refer to me as an I because I'm not human, and blah blah blah. And so I suspect if you ask that question, there's probably a pre-canned response that OpenAI wants you to read. But more seriously, I suspect it would say that Alan Turing believes that I have passed the Turing test.
Good answer. Okay. Is a large language model anything more than a statistical means of reflecting our linguistic culture?
No, you nailed it. No, it's exactly that, right? So it's ingested all of the words used in particular sequences that are out there in its training data. We know that it's absorbed vast quantities of the internet and books and all of the papers that are in PubMed, presumably, and anything that's out there, it's taken in. So that's what it's reflecting, is those statistical probabilities of the word sequences. Obviously, a very high parameter model, very big model, and so it's capturing a lot of the kind of very nuanced. But it is ultimately just effectively copying and pasting together snippets of text that it's seen in its training data.
I just realized I skipped over one of the questions in the queue here. Does the advent of this new way of encoding language foreshadow the demise of traditional symbolic and ontologic knowledge representations?
Well, I mean, our statistical machine learning colleagues would certainly love for that to happen. But I think, back to the comment that we were discussing earlier about integrating knowledge into these models, I think if we can really demonstrate that that's valuable, then, through the weight of the evidence, we will see that a purely statistical model isn't sufficient to address those higher level reasoning objectives and the goal-oriented behaviors that we really need these systems to try to work towards. So I think the proof will be in the pudding, but I think the limitations of the existing systems will eventually mean that we realize that we have to work together in a hybrid kind of way. The other thing that I would say is that there's synergies between these, because a lot of my own work is about information extraction. So we're using actually large language models, not in a generative way, but in a way to produce knowledge from text. So we're essentially trying to take text and transform it into a structured knowledge representation in a targeted way. And, that structured knowledge then can become the input to some downstream process that uses the knowledge. So, you end up with interesting kind of combinations and synergies between these approaches.
Well, Karin, that about brings us to the end of the allotted time. We just can't thank you enough, both for you and Mark, to have had your conversation, which is recorded for posterity, and I'm sure will be watched into the ages. It'll be funny to look back on this 10 years from now and examine this conversation in light of what has transpired. But we are enormously appreciative for that, and as well for your excellent answers to the questions and comments posted by our audience. So thank you again. Have a great day.
Thank you so much for having me. It was my absolute pleasure. It was really fun. Thanks.
Bye-bye.